Well, what to do? This is your boy Big Rich right here, about to give y'all pretty much of the JCS engineering course. Pretty much what I'm gonna do in this course is explain a few things, far as give you the visual representation, what we covered in the recording on our first lesson. Pretty much the basics of sound. Now, what I'm gonna explain to you in this particular segment is gonna explain the frequency. Now, as you know, frequency is pretty much a deal where it represents a cycle of a waveform per second, and that's how you come about with your different frequencies, as far as 20 hertz, 30 hertz, 120, 1000, and 500 hertz, and pretty much those are cycles in a waveform per second. So I'm gonna give y'all a visual representation. Now, as a waveform is, you have a zero axis line, and what I'm referring to is, you know, say for instance Pro Tools or any other DAW, you'll see on the waveform, pretty much there's a zero axis line, okay, and that represents the waveform crossing that zero axis line for the cycle. Okay, so I'm gonna give y'all a visual representation of that. All right, so pretty much right here you're gonna have the zero line that I'll tell y'all about. All right, now pretty much that's your line right there. Now what we're gonna do is we're gonna draw a waveform, you know what I'm saying, based on this line. All right, and I'm gonna draw one of them just to give you a representation of one cycle per second. Let's go. All right. Now, my friends, as you see what I drew, the circle, that is one cycle per second. Alright? Now, pretty much what this representing is anytime you have a waveform that crosses, that starts at the zero and it goes up in amplitude and comes down, or should I say it goes up far as the peak value on the waveform, and it comes back down to zero, and it goes under at the negative, and then it comes back up, you completed, you know what I'm saying, a cycle. You have to go positive to negative and come back to zero. As you see, this is the zero line, this is the positive, that's the negative. See the positive and the negative? That equals one cycle per second. As y'all probably can see, that one cycle per second, feel me? Alright, cool. So I'm going to erase that. Now, as you see, that was one cycle per second. Now, one cycle per second pretty much means 1 hertz. And the cycles are measured in hertz, or frequency is measured in hertz, by the way. So what we're going to do with our line, we're going to make a 2 hertz waveform. Let's get it in. Alright, now as y'all see, I added to this waveform. Now, it's not looking the same as our first cycle, but that's pretty much, waveforms aren't supposed to be the same. You know what I'm saying? And pretty much what we have is a complex waveform. It might look like a sine wave, but you know what I'm saying, it's complex because the sine wave is not the same throughout the cycles or the period of time with this waveform. So right now, again, we have positive, negative. Alright, now let's draw the cycles. This is one cycle. You see that? One cycle right there. And then this right here is 2 cycles. You feel me? So that's 1 cycle, 2 cycle. Alright? Which gives you two cycles per second, equaling 2 hertz. If y'all can see that, that's 2 cycles per second, 2 hertz. And that's pretty much a waveform. Now, let's just say we take that 2 cycles and we times that by 100. That'll be 200 cycles in 1 second. And I pretty much don't have that much room on my dry erase board. So I just want to give y'all an example of what a frequency would look like in a period of time far as a waveform goes. Alright, let's go to our next little topic. Alright, cool. Now in this next little segment we want to talk about you know what I'm saying, the amplitude of a waveform. Now I pretty much showed y'all in the last little deal far as the waveform goes, you have the plus and the negative. So let's draw a waveform again and explain what a waveform is in amplitude. Alright, so again we have our line. Alright, as y'all see we got a line, and let's draw our waveform once again. Alright, now again, waveforms aren't pretty, as you know, in most Pro Tools sessions or whatnot, but as you see, my old funky ass waveform there pretty much is a 1 cycle, 1 hertz diagram we have. Now the amplitude, let's just say this is 0, right? 0 amplitude. Now, what 0 amplitude is, pretty much, you can look at it as volume. You know what I'm saying? So, this is 0, and then you have 1, 2, 3, 4, 5, 6, and 7. Okay? That's all the plus. Then you have 1, 2, 3, 4, 5, 6, and 7. That's all negative. Alright? I don't know if y'all can see that or not, but that's 1, 2, 3, 4, 5, 6, 7 going up on the positive side, and 1, 2, 3, 4, 5, 6, 7 going down on the negative side. Now, as you see, the RMS value, now if y'all don't know about RMS value, you probably see that on VU meters. Now, VU meters will give you the RMS value. What the RMS value is the median value of a waveform or a particular signal. Alright? Now, pretty much what an RMS is going to be the median. So the RMS will sit around, and I'm going to give you an example of where the RMS will sit within this 1 cycle waveform we have. RMS should run about right here and right here. Alright, now that's your RMS values, where those lines are, as far as this waveform goes. Now the peak to peak will be at the top, you know what I'm saying, of the waveform. Alright, so what we're going to do, we're going to draw the peak to peak. Now the peak is going to be from the peak is going to be at the tip top of this waveform, and that's going to represent the peak of the waveform, if that makes any sense to you. Now you have a peak to peak value, so you'll go from peak of the positive all the way down to the peak of the negative. Let's draw an example of that. Alright, now as y'all can probably see on this one, the peak is at the top. I drew the arrow, and the peak is going to be right here. That's going to be your peak value right there. So peak to peak value, that's how you'll get your peaks on your waveforms. Get it? Got it? Good. And also too, the peak will be from 0 to whatever it is. So it'll be right here, 0 to the peak. So our peak right now is at 7, let's just say 7 plus, and we're at about 6 plus, 6 negative, I'm sorry. Let's erase that. 6 negative. Down this way. I don't know if you can see that, but that's 7 decibels, or should I say, yeah, 7 decibels peaking, and negative 6 decibels peaking down. So that's pretty much what the amplitude of a waveform is pretty much representing. Let's go on to our next segment. Alright, pretty much in this particular example or segment, we're going to explain the harmonics, harmonic fundamental of a waveform. Now, as I've explained to y'all, you know how you have on the keyboard, you have C3, C2, and C4. Okay, C2 is going to be a lower octave than C3, and C4 is going to be a higher octave than C3. Right? Okay, cool. Now, according to the waveform, C2 is going to be a longer waveform, and C4 is going to be pretty much a shorter waveform with more wavelength with that goes and stuff like that. So just to give you far as wave in time, of course. So just to give you a example, let's go in it. All right, so pretty much with a C2 on the keyboard, C2, you might have a waveform like this. All right, pretty much a waveform like that. Now C3 might look something like this. As y'all can probably see, that's a C3 right there. As you see, the wave length in time increases. Okay? Now on the keyboard, when you play the high note, which is going to be C4, this is what it might look like. Alright, so that's pretty much what it would look like. C2, C3, and that C4, you know what I'm saying, on the keyboard, your wavelength far as time goes is gonna the waveform is gonna be a little, you know what I'm saying, it's gonna be a you know, you're gonna have a little bit more waves in that far as the harmonic content of the waveform, and it's gonna it's pretty much just going to increase as you go up to the first and the third, excuse me, the first and the second and the third harmonics. Okay? Alright, so that's pretty much what that example means. Take a look at it again. C2, C3, and C4. As you go up, far as pitch is concerned with a waveform, the harmonics are going to increase far as the waveform, or the harmonic content of the waveform is going to increase far as pitch goes with harmonics with waveforms. Let's move on. Alright, pretty much in this segment, we're going to talk about the four complex, or should I say the four basic waveforms, which is that goes. You have a triangle, a square, sine, and sawtooth. So let's draw those waveforms just to give you an example. Alright, so pretty much a sine waveform is going to be like your 808 type of sound. Alright, that's pretty much your sine waveform. Now let's draw a triangle. Alright, now that's pretty much a triangle waveform right there. Alright, cool. Now let's draw your sawtooth, which is a pretty hard one. But it's similar into the sawtooth. Alright, so pretty much that's what a sawtooth, my drawing sucks, but that's pretty much what a sawtooth looks like. It looks like a triangle, and you kind of bent it and moved it, you know what I'm saying, you kind of turned the triangle a little bit to the right at a 45-degree angle. And that's pretty much what a sawtooth looks like. Now let's draw our last basic waveform shape, and that's going to be the square. Alright, now as you see, that's a square waveform. Alright, so pretty much that's what that is. Now off of these waveforms, you can create all kind of different waveforms by way of synthesis. And you can create you know what I'm saying, complex waveforms. And of course with all kind of different instrument sources like pianos, drums, human voice, you know what I'm saying, the beating of a cardboard or the touch of a glass or ticking on a wine glass with a fork. You can create complex waveforms, and complex waveforms is not going to look like these four you know what I'm saying, waveforms right here. So let's just give you an example of what a complex waveform might look like. Alright, now my folks, that's what a complex waveform might look like. It's complex because you really can't define the four basic waveforms out of the waveform signal. But as you look at it, it's pretty much complex. Hence the reason it doesn't have any form or shape to it. You know what I'm saying? So, you know what I'm saying, like, let's just say any type of noise might create this type of signal or waveform. Alright, cool. Let's move on. Alright, now pretty much this is the last little bit right here. I'm going to show y'all as far as the visual representation this goes. And I'm going to draw a waveform pretty much explaining the envelope of a waveform. The envelope is pretty much your ADSR. If you don't know what the ADSR means, you've probably seen this on a lot of common instruments for samplers and synthesizers go, and also two drum machines. And pretty much what a envelope for as ADSR concerned, it explains four basic terms, and that's pretty much attack, decay, sustain, and release. Now let me draw a waveform just to give you some examples. As a matter of fact, I'm gonna draw 3 of them. Alright, now as y'all see, we got 3 different waveforms. And what we're going to do right now is going to label these and find out where the attack at on all 3 of these. Now the attack is going to be right there at the start point, which is going to represent the transient of the waveform. Get it, got it, good. Let's draw the attacks. And I'm going to label these by A, D, S, and R. The A, right there. A. Whew, that's messed up right there. Alright, and the A. Alright, now as y'all see, the attacks, you know what I'm saying, on the first one, you know what I'm saying, is very not that defined, but it's definitely the start of the waveform. Now the second one, you're going to see the attack is a little bit more defined, and that's going to be the attack right there. And the third one is kind of like a snap or a clap or a snare hit, and that's pretty much going to be the attack. You know what I'm saying? The first initial point of the waveform or the transient. Okay? Alright, now let's draw the decay. Now the decay is where, you know what I'm saying, it's the period of time from where the attack starts until it starts sustaining far as the period of time of the waveform. Okay, so let's recognize where the decay is. And now the decay is not going to be something real long, so I'm going to try to draw this the best way I can. Now as you see, my D's at the top, at the top of the waveforms, you got to see where the D's are. Now that's the period from the attack and where the waveform starts sustaining just a little bit. The first one is a little bit too long for my example, so I apologize on that, but that's the decay time. The second one is going to be just that little bit right there, and that's going to be the decay time as well. Now the third one is very short decay time, and you really can't do nothing with that when you want to edit it as far as using it on the sample or whatnot. Now let's draw your sustain. Now your sustain is pretty much going to be the period of time from where the decay ends until it starts releasing off of releasing on the waveform. So let's draw your sustain. Alright, now as you see where I drew the S's you know what I'm saying, at the bottom of the waveforms, you'll see the S's. And that's pretty much going to represent the sustained time of that waveform before it starts to release and dissipate far as the signal goes. Okay, now envelope is an amplitude type term, so it involves the amplitude of the waveform. And as you see, the sustain is pretty much the sustained volume. Okay, and it's pretty much going to hold for the waveform until it starts to release from the amplitude of the waveform, and I'm going to draw the release for y'all guys. Now, as y'all can see, you see the R's. That's pretty much going to be the release of the waveform. It's the last part of the waveform that dissipates from a certain period of amplitude all the way down to 0. As far as decibels is concerned. And if you don't know what decibels mean, pretty much decibels is a measurement of amplitude, which represents volume. Okay, so this pretty much is it for the visual representation of lesson 1 in the JCS engineering course. If you have any questions, y'all can hit me up on the email jcsproductions@gmail.com, or you can pretty much hit me on Twitter at BigRich, BIGRYCH, and also follow us on Twitter, at Joint Chief of Staff Productions, and excuse me, that's going to be at JCS Productions. You know what I'm saying? So salute to you, glad you're watching this video, hope you're learning something, and tune in to next week's video. We're going to be talking about mics and the theory behind mics and everything about a mic and what it do. Alright then, see you then. Peace.